Hello friends, welcome to datamaking.com. In this video I am going to explain you overview of Apache Hadoop. So recent days you might have heard about big data Hadoop. Let me introduce these terms and what it can do for you. What is big data? According to the Wikipedia definition, big data means it's a large data sets which cannot be handled by the traditional software tools. So big data, according to the Wikipedia, 90% of the data is unstructured data and 10% of the data in the web is structured data. We'll see what is structured data, unstructured data in the following slides. So big data characteristics. The main three characteristics of big data is volume, velocity, variety. What is mean by volume? Basically it says data size. What is the size of your data? So if your data size in terabyte, petabyte, so it's a big data with respect to volume. The next one is velocity. What is velocity? The rate at which the data is generated. Basically, so that is meant for big data with respect to velocity. So speed at which the data can be changed. Example, if you make any tweet in the Twitter, so you might get a retweet or the following tweet in the speed. So that is the velocity. The last one is the variety. Variety is actually what are the types of data. Basically variety means it's a structured data and unstructured data and semi-structured data. So again, structured data can be RDBMS relational data, you can say structured data. Semi-structured data can be any XML or any email, anything data. The partial data can be structured and the other partial data can be unstructured. Unstructured data is the data in terms of videos, files, audio files, or any document files, text files are called unstructured data. So these are the three main characteristics of big data. So in this slide we'll see how the big data is evolved from the traditional systems. So in the earlier days, the software are used in the terms of ERP systems. So those systems generate the data is in the size of megabytes and gigabytes. Then later CRM and web technologies has come. Then the data which generated by web applications and other data sources. So those data are generated in the terms of the size in terms of terabytes. So when the social media came into the picture and other IoT, that is the Internet of Things, those sources started generating lot of huge data which is in the form of petabytes and more volumes. So these are the stages where the big data is evolved. So these are the in this slide These are some of the web giant who generate big data like Yahoo, Google. Google does indexing for the documents available in the internet, and Facebook, it has a lot of users, and some of the online purchasing websites generate a lot of data, and the LinkedIn and tutors also generate a huge number of data. Now let me introduce what is Hadoop. Hadoop is an open source framework for storing and processing large data set. Hadoop provides fault-tolerant distributed system for storage and parallel computing for processing. So Hadoop does not use any high volume or expensive systems. It can run on commodity hardware, that is cheap hardware like desktops and laptops. Fault-tolerant system. So execution of job continues even nodes are failing. Example, if I have multiple nodes which form the cluster. Here cluster means the grouping of system, so the systems are called a node. If I have a cluster with a 5 nodes, even if one node goes down, I am able to execute the job without any problem. That is fault-tolerant system. It has high reliable and efficient storage system. So main features of Hadoop: distributed storage, fault tolerance, horizontal scalability, it's open source, and commodity hardware and parallel processing. So some of the application where Hadoop can fit is web log processing, page indexing, page ranking, and complex event processing. So as I mentioned previously, Hadoop has two major components. One is HDFS, Hadoop Distributed File System, and another component is MapReduce, short form is MR. It's a parallel processing of data. So Hadoop uses Masterslave architecture, means you have a single master and you will have multiple slave nodes which form the cluster. So the master node which gives jobs to the slave nodes. The slave nodes will execute the jobs and send the result, aggregated results. So HDFS. So HDFS is Hadoop Distributed File System, means you store your data in multiple systems in distributed manner. So to provide fault tolerance, it replicates your data into multiple systems. So basically it splits your data in equal size and store in multiple systems. For fault tolerance, it replicates your data also, means it duplicates your data. So how it is splitting your data? As I mentioned, it's a equal size, right? So the size is called block size. So by default it's 64 MB. So if you give 1 GB of data to HDFS to store your data, it splits based on the 64 bytes default block size. So you will get 16 blocks. So in this slide there is a file which is splitted into 4 blocks: B1, B2, B3, B4. So I have 5 node cluster. One is configured as master node and the other 4 are slave node. So B1 is stored in 3 machines. So how it is replicated or duplicated is based on the replication factor. So by default it is 3. So if I have a 1 block, that is also replicated in 2 other nodes. Okay. So let me introduce 2 process or daemon used in HDFS is name node and data node, and one more is secondary node which we'll see in later stage. So name node is a process or daemon which takes care of metadata about your data. Basically, so if you have a file which is split into 3-4 blocks, so where my blocks are stored in the slave nodes, that information stored in the name node. The other slave node called data node, it's a daemon. Okay, so a process which actually stores your data, that is blocks. So if you see this diagram, B1 is in 3 places, 3 nodes, and B2 is also 3 places. Suppose if one node fails, for example the 4th node fails, the data which 4th node has is B1 and B2 and B4. So other the duplicate record is there in the other nodes, so we can take it from the other node. So even failure occurs, there won't be any problem. Then the next component is MapReduce. So MapReduce is a simple programming model which is for distributed parallel processing. Okay, so MapReduce, it's a 2-stage processing. One is map and another is a reduce. Okay, so in map, so when you work on MapReduce, you will be processing your data in terms of key value pairs. Okay, so if you take a map face, or we can say mapper, reduce face called reducer. Okay, so if we have a file, okay, the previous example we have a file with 4 blocks. Basically for each block, okay, in MapReduce terms is called as input split. Okay, so your file is, if it's splitted and stored in HDFS, means it's a block. When it comes to MapReduce paradigm, it is called input split. So in this example I have a file, input file, which has a 3 input split. So 3 mapper will be running on each input split. So inside mapper class I will have method called map, which will be getting key and value. So example K1 and V1, key 1 and V1, which can generate 0 to n number of key value pairs based on the logic you written in map method. The next stage is called reduce stage. In a reducer program or class, you will have a method called a reduce, which will take, so whatever the output written from the mapper is called intermediate result. That intermediate results from each mapper is sorted and shuffled, and it's sent to the reducer. If I have one reducer, it will send all the grouped data to a single reducer. In this example we have only one reducer. The number of reducer we can configure. So in this example we have one reducer, so we have 3 mappers. Those 3 mappers generates intermediate data, those are shuffled and sorted, and the grouped data is sent to the reducer. Basically, in reducer, for reduce method, you will get key, that is K2, and list of V2. With respect to that particular key, what are the grouped values that will be coming input to the reduce. So you can write what are the logic you want to basically in reduce method you will have some kind of aggregation logic. Based on the aggregation logic, it will emit the K3 and V3, the final key and value that will be written in the HDFS. So next, Hadoop ecosystem. So we know what is Hadoop. Hadoop is a open source framework which has two main components, MapReduce and HDFS. Other ecosystem components. These are some of the ecosystem components in Hadoop. We have many more components. These are the basic components. We have Apache Peak. It's a scripting language for doing data analysis, the data which resides on HDFS. So you can it has set of operators or commands which using that you can accomplish a lot of operation like grouping operation or filter operation. So when you write a big script based on your programming logic, based on your logic, so that will generate the MapReduce job based on your big commands or script. Automatically it will generate the MapReduce job and it will run on the input data which resides on HDFS. Next component is Hive. It is like SQL language. So if you have a data in HDFS in a structured manner, okay, so you can create a table in Hive on the table which resides on HDFS. Then you can write a query to write a SQL syntax to query the data from HDFS. So Hive mostly works on structured data. So even though your file is a flat file in HDFS, it should be in structured manner. So it supports CSV file, JSON files, and other structured format files. The next component is Scoop. Scoop is a data transfer tool, you can say, from RDBMS to HDFS and Hadoop, or Hadoop to RDBMS. You can import and export data between RDBMS and Hadoop. The next component is HBase. It is a column-oriented database for real-time read and write to the HDFS. So in HDFS actually does not provide any update, because once it is written, you can do lot of read. You cannot rewrite. Okay, so you have to delete and you have to insert the modified file into the HDFS. So if you want to have update and read it on your HDFS data, then HBase is a NoSQL. NoSQL is another category which is evolved in recent years. NoSQL means it's not only SQL. Okay, so HBase is a column-oriented NoSQL database which provides a real-time read rate. The next component is Flume. It's for stream processing. Okay, you can get log data from server logs, or you can get any files into HDFS in the streaming manner. In the top you have another component called Uzi, which is a workflow scheduler to manage your Hadoop jobs. Suppose if you have n number of MapReduce jobs, okay, if you want to schedule it in particular time, so you can write a workflow to run your job in a sequential order. You can write you can run pig script, Hive script in the Uzi scheduler, Uzi workflow. Use Hadoop use cases. Hadoop basically one of the use cases web log analysis. So if you take Flipkart, Amazon, whenever you purchase any product in Flipkart, Amazon, they write the logs in the log files, the transaction details. So if you want to process those logs and give insight to improve the business, so we can do log processing using Hadoop. Okay, so that is one of the use cases, and there are many more use cases where Hadoop can be used. Data exploration, 360 view of customers in healthcare, and it can be used in security and intelligence extensions where you can detect frauds. Okay, and you can build the data warehouse, okay, using Hadoop. Okay, so Hive is the one of the tool which provides data warehouse capabilities. So these are the places where Hadoop can fit into. So who uses Hadoop? There are many more companies which uses Hadoop, like HP, Visa, Samsung, IBM, Twitter, Yahoo, and eBay, Amazon. These are some of the companies which extensively uses Hadoop. And so there are some of the ETL tool or the data warehousing tool which already integrated with Hadoop, like Pentaho, Talend, Netissa. So distribution, Apache Hadoop is the open source distribution. Other than that, you have Cloudera, which is a company which has commercial distribution that provides many more features other than Apache Hadoop, and other distribution called Hortonworks, and some of the other vendors also who provides Hadoop distribution like MapR. Prerequisite is to learn Hadoop. You should have basic Linux commands, and if you have core Java basics, it is good, but it is not compulsory, because you have other tools where non-Java programs can use, like Hive. So if you have a SQL background, database background, there is a component called Hive which can be used by the non-Java program. So Pig is another data flow language. It's a simple syntactical language which can easily learn and do it if someone don't want to write MapReduce job using Java. So MapReduce programs can be written in other scripting language like Perl, Python, and Ruby. So if you have SQL background, that is well enough. So Hadoop is not big data. Hadoop is one of the framework which can solve big data problems. Thank you very much.